Hello friends, welcome to this new lecture on computer graphics. In this lecture, we are going to cover the algorithm DDA. What is a DDA algorithm? DDA is a line drawing algorithm. So we are going to understand how to draw a line using the DDA line drawing algorithm. So let's get started. Now, to get started, we need to understand what is a line. So we should know that line is something which is infinite, okay, but we bring it to a fixed size, or we can say to a fixed length, with the help of the start point and the end point. So obviously line should not be a continuous line, it should be a terminating line. Now the density of the line should be constant. That means the thickness, okay, the density of the pixels where when we are talking about, okay, so we need to see to it that the thickness of the line is constant from the start point till the end point. Now this thickness should be independent, okay, of the length of the particular line or the angle that it makes with the x-axis. So it should be independent of that. So and the last point, line endpoint should be specified. So this and the first point is almost similar. So you need to know that we need to have a endpoint for a line. So now the start point of the line is normally represented as x1 comma y1. So x is the distance from the x-axis and y is the distance from the y-axis. So it is denoted as x1 y1, and the endpoint for the line is normally denoted by x2 comma y2. Now we have two basic algorithms for line drawing, DDA algorithm and the Bresenham algorithm. But we are going to cover the Bresenham in the next lecture. Okay, today we are going to focus on DDA algorithm. Now, so first let's understand what is a line. So line is normally shown with a formula y equal to mx plus b. Now, what is y equal to mx plus b? So let's start with plus b. So b is the distance from the origin till the point where the line intersects with the y-axis. So that is called as a y-intercept, wherein the line intersects with the y-axis. So that is the distance from the origin till the point. Okay, so it can also be denoted as, you can see, y-intercept equal to b equal to y1 minus mx1. So it is y minus mx. Now, slope of the line is normally what it is calculated as delta y by delta x, which is y2 minus y1 divided by x2 minus x1. That is also can be represented by tan theta. So tan theta is the same delta y by delta x. Now, so what is the DDA algorithm? DDA algorithm stands for Digital Differential Analysis. Now, in this algorithm, we use this algorithm for scan conversion. That means we are going to use the basic primitive, that is points, and we are going to plot the line with the help of points. So that means this point has to come in some sequence, one after another. Okay, they should be very close to each other to represent a particular line. So how to get started? So let's take some examples. Okay, so you can see one of the examples over here. In this example, you can clearly see that my line is, suppose I say x1 y1 is below, x2 y2 is below, above. So in this case, you can see the y distance of y is more and the distance of x is less. So delta x is less, delta y is more. Okay, then another example, you can see delta y is less, delta x is more. Now, we have to choose the step size, okay, number of steps that we can take between x1 y1 and x2 y2. That means the number of points that we could have, okay, between x1 y1 and x2 y2. So more the number of points, the more the line would look continuous. Okay, if the less the number of points that we plot between x1, y1 and x2, y2, it will look like a dotted line. So to have more number of points, okay, we the step thing, okay, has to be dependent on delta x or delta y. So you can see that if we choose delta y, only then we get more number of points between x1 and x1, y1 to x2, y2, wherein delta x will give us less. So let's figure out how. So you can see that if I choose uh, delta y. So you need to understand that the step size is normally of 1. Okay, so 1 means from one pixel to another. So how many intermediary pixels we might have if we use delta y? So you can see we start from here. So this is the first intermediary, second intermediary point, third, fourth, fifth, sixth, and seventh, and then eighth is the final point. So we have 7 intermediary points. Okay, so using the 7 intermediary points, okay, the my line, okay, would kind of look continuous, because you can see that if I'm having this points plotted here, so this would be the for this particular pixel over here. Okay, this point, on the line, the pixel would lie somewhere over here. For this particular intermediary, the point would lie somewhere over here. Okay, for this particular intermediary point, the pixel would lie somewhere over here. For this intermediary, the pixel would lie somewhere over here. So you need to understand that the more the number of pixels, the more the line looks continuous. Now, suppose if you are going with delta x for steps, so the number of steps that would be there, okay, the intermediary steps will be just two, because this is the start point, this is the end point, right? Uh, for the x-axis. Now, so intermediary points are only two. So with only two, you can just see that if I choose this first intermediary, I'll be having just 1 point over here, right? And for the second intermediary, I'll be having the second point over here. So you can see I will just have 4 points. So this will be the starting point. Somewhere the other point will come over here. Okay, the third point will come over here somewhere, and finally the final point. So that would look like a more like of a dotted line and not a continuous line. So it's better to go understanding the number of steps that could be taken in the DDA algorithm. We should go with the delta which is higher. So in this case, delta y is higher. In this case, delta x is higher. So let's understand this with the help of an example. Okay, so uh, we're going to start with the help of an example. Let's plot some points. So okay, so how does it work? So you can see that I have put up some examples over here, the framework of the example. So let's say that we want to plot a point from 3, comma 4 to 11, comma 4. Okay, so now in this case, what will I be having? It's 3, comma 4, right? To 11, comma 4. Okay, so x2 minus x1 would be what? So you can see it is 11 minus 3, right? That's 11 minus 3, which is coming up to 8. Okay, for y2 minus y1, you can see that it is just 4 minus 4, which is coming to 0. So obviously, there's no y inclination to this line. Okay, now delta y by delta x, so delta y is 0 divided by 8. So you can see that this is less than 1. Okay, so slope is negative, and the slope is negative. We know that we have delta x which is greater than delta y, as delta x is greater than delta y, so the number of steps, okay, so we can say that this is number of steps is dependent on delta x. So what is delta x? That is 8. So number of steps taken would be 8. So let's find out the x increment and y increment. X increment is delta x by steps, that is 8 by 8, right? So it is 8 by 8, which comes out to be 1. Okay, and then we can see that if we go for y increment, we'll be having what? It's 0 divided by 8, and that comes to 0, right? So now let's start making the table. So we start from 3, comma 4, right? So, and we see that we have x increments, and we see that we have y increments, which is normally 0. So if we go for the first iteration, we'll increment the x by 1, and the y increment, we see that there is 0 increment, so obviously the value will remain the same. In the next iteration again, the x would increase to 5, this will remain the same, then this will go to 6, this will remain the same, this will go to 7, this will remain the same. Similarly, 8 to 8, 4, we have 9, 4, then we have like 10, 4, then we have 11, 4. So you can see that we have reached the destination. And so if you plot the point, this would look something like this. Right. So you can see a straight line being formed. Okay, it's a straight line. So now let's start in another example. So let's say in that example, we want to go from 4, comma 3 to 4, comma 10. Okay, so let's say we are going from 4, comma 3 to 4, comma 10. So this will be 4, comma 10. So when we do x2 minus x1, it is 4 minus 4, which is 0. Okay, and then over here we have what y2 minus y1, that is 10, comma minus 3, which is 7, right? Then we have delta y by delta x, that is 7 by 0, which is infinite, which is greater than 1, so slope is greater than 1. So number of steps are dependent on the delta y in this case, as delta y is greater than delta x. So the number of steps that would be taken will be how much? It will be equal to delta y, which is 7. Now, so delta x would be what? The delta x is 0 divided by 7, which is 0. Okay, and then in here you can see 0 divided by 8, sorry, 7 divided by 7, which is 1. So this is how it would be. So let's delete the last example and let's get started. So we have 4 comma 3. We have 4 comma 3. Now, when we start incrementing, we can only increment y. You can see that the increment is normally 0. So next will be 4 comma 4. Next would be 4 comma 5. Then next would be 4 comma 6. Then next would be 4 comma 7. Next would be 4 comma 8, 4 comma 9, okay, and 4 comma 10. So you can see we have reached x to y2. So we started at 4 comma 3, 4 comma 4, 4 comma 5, 4 comma 6, 4 comma 7, 4 comma 8, 4 comma 9, 4 comma 10. So again, you can see this is a vertical line that's been plotted with the help of the pixels. Right. So now let's proceed ahead with another example. Let's see if now let's work out with the slope. So let's say that this is 4 still 4 comma 3, and let's say that this is like 12 comma 10. Okay. So if we do that, we'll do that x2 minus x1, that is 12 comma 4. 12 comma 4 comes out to be 8, right? And then we have y2 minus y1, that is 10 minus 3, which is 7. Okay, delta x by delta y, we see that, sorry, delta y by delta x is 7 divided by 8, which is less than 1. So we can clearly say that we have the number of steps with respect to delta x as delta x is greater. Okay, so number of steps equal to 8. So now we have delta x by number of steps, that is 8 by 8, which is equal to 1. And we have delta y as 7 by 8. Okay, so how much is n by 8? It is almost like a point, how much? 6 eighths of, like 8 eighths are 64. 8 eighths are 64. It's towards the point 0.9 side, but still we'll just take it as 8 eighths are 64, and after that 60 again. So 7 eighths are 56, 8.87 kind of thing. Right. So this we can say that it is zero point 0.9. Okay. So now let's get started with this. Okay, let's take out the old example and we are starting with 4 comma 3. Okay, 4 comma 3. So next step that we'll have. Okay, so for x increment is proper, we have to do 5. Then here we'll be having what? 3.9. Right. Then in the next iteration we'll be having 6. Then this 3.9 plus zero point 0.9 become 4.8. Right. Then we'll be having 7 over here, and here we'll be having 5.7. Right. Then here we'll be having 8, and here we'll be having 6.6. Then here next iteration will be having 9, and this 6.6 will turn into 5 point, sorry, it is 7.5. Then this will be 10, 10 point, and this will be 7.5 plus zero point 0.9, so this will be 8.4. Then you have 11 point, and this will be 9.3. Then you have the 12 point, and this is 10.2, right? So let's see, we'll use the rounding of the y. So it will be, this will be 3, this will be 4, this will be 5, this will be 6, this will be 7, this will be 8, this will be again 8, this will be 9, uh, and this will be 10. Right? So let's plot the points now. Okay, I'll just take out the previous points, and we are starting from 4 comma 3, which is here. Right. So after this, we are going to plot what? 5 comma 4. So it is 5 comma 4. Then we have next point as 6 comma 5. So we have the 6 comma 5. Then we have 7 comma 6. So we have 7 comma 6. Then we have 8 comma 7. We have 8 comma 7 here. Then we have 9 comma 8. We have 9 comma 8. Then we have 10 comma 8. So this is kind of like this, 10 comma 8. Then we have 11 comma 9. So we have 11 comma 9. Then we have 12 comma 10. So you can see I'm having a line over here. It's not actually a complete straight line, but you can understand, like currently we're having a pixel of only 20 by 20, but your screen is like almost 1920 by 1200, the screens right now. So you can see so many pixels are there, okay, and it is so dense set of pixels. So obviously when the pixels are so close, this would seem like a straight line. So now let's get started with another set of examples. So here we have x1, y1, which is 3, 17, and here we have x2, y2, which is 8, 5. So let's find out the delta x, that is x2 minus x1. So x2 minus x1 is 8 minus 3, right, which is equivalent to 5. And in the y case, we have y2 as 5 minus 17. So 5 minus 17, which is equivalent to we have 12, right? So now we have delta y by so this is minus 12. Okay. Now we have delta y by delta x, which is going to give us the slope. Just that is 5. Sorry, that is minus 12 divided by 5, right? So that would be something around like 2.4. 2.4, which is minus 2.4, right? So because of this, we understand that so now here we have a negative delta y. Okay, so should we take the sign into consideration, the negation sign? The answer is no. We work with the absolute values. We need more number of points on the screen. So we can say that y-axis is still longer. It doesn't matter what the sign is. So we can go ahead with the number of steps as 12 because delta y is giving me 12, right? So in this case, delta y is actually greater than the delta x. So now if we look at the steps over here, so it will be delta x, that is 5 divided by, and we have steps as 12. So we can say that 5 divided by 12 is how much? So 12 fours are 48. So we can say zero point 0.4. We have almost close to 5 then. Okay, and we can say for this is 12 divided by 12, which is equivalent to 1. So let's get started. We'll start from 3 and 17. Right. So but in this case, we forgot something. What have we forgotten? We have the delta y as minus 12, right? So if this is minus 12, this is minus 1. Okay, so we need to take that into consideration. The sign now. So the next point after the first iteration from 3, 17 would be what? So after 3, 17, the x increment is of zero point 0.4. So we can go with 3.4. And here it is minus 1. So this will turn into 16. Then in the next iteration, this will be addition of zero point 0.4. So it will become 3.8. This will be 15. This will become 4.2. This will become 14. This will be 4.6. 4.6. This will be 13. This will be 5. This will be 12. So we still have a long way to go. So we'll increment 5 to 5.4. This will come down to 11 because it's minus 1. This will become 5.8. This will become 10. This will become 6.2. This will become 9. This will become 6.6. This will become 8. Right? Uh, then this will become 7. This will become also 7. Right? We have to come till what? 8, comma 5. This will become 7.4. This will become 6. Right? And this will be 7.8. And this will be what? 5. So you can see we have y decremented one at a time: 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5. Okay, and this is incremented in 0.4, so we have 3, 3.4, 3.8, and accordingly we reach till 7.8. But now we have to round it, as round is an important function in DDA algorithm. So this is actually a disadvantage of DDA algorithm. We'll talk about it later. So let's start rounding. So this will become 3, this will again become 3, this will become 4, this will become 4, this will become 5, this will be 5, this will be 5, this will be 6, this will be 6, this will be 6.6 will become 7, 7 will stay 7, 7.4 will stay 7, 7.8 will become 8. So now we have x rounded and y to be plotted. So we start with 3 to 17. This is 17, and I hope we are at 3. Yes, we are at 3. So that's the first point that's plotted. Right. The next point is what? 360. Okay, then the next point is 450. So it's here. Then the next point is 440. Next point is 530, right? The next point is 512. The next point is 511. The next point is 610. Then we have 6 9. Then we have 7 8. Then we have 7 7. Then we have 7 6. Right. Then we have 8 5. So this is it. So we have plotted the line. Now let's proceed and understand the working on the pseudocode. Okay. So this is the pseudocode of the algorithm. So you can see we have algorithm of DDA wherein we pass x1, y1 and x2, y2. We calculate delta x and delta y. Then we clearly see that in this case we don't use the signs over here to understand the number of steps. So the sign is independent, the steps is independent of the sign, and so we use absolute values of delta x and delta y. So you can see whatever is greater is given to the steps to become the number of steps. Using that number of steps, okay, we get the x increment, which is delta x by steps, and y increment, which is delta y by steps. After that, we have the for loop. You can clearly see. So the steps for loop goes from the 0th point, that is your x1, y1, till the last point, okay, till we complete all the steps and reach the destination, that is x2, y2. So as soon as we start, we plot the x1 and y1 pixel, okay, onto the screen, and then we increment x1 and y1 from the values that we have got over here, x increment and y increment. And after this is then again in the next loop we plot the x1 and y1, which is the incremented values, and we keep on going until unless we reach the endpoint, that is x2, y2. So this is it. So there are few disadvantages in DDA algorithm. You need to understand that here we should also had a round function, because you know that in the examples we saw that we have to round it. So rounding operation takes a good amount of processing time, and also you see that we work with floating numbers. So using floating numbers, having decimal points, okay, creates a lot of processing time. Okay, so this is all disadvantages of DDA line drawing algorithm. So you need to understand that the algorithm has to be very fast to bring about the scan conversions from point to a particular line or to any particular kind of design, whatever. Okay, so to do that, the algorithm need not spend working and doing calculation on floating point values, because that will be just an additional burden to the algorithm. It will increase the time complexity of that algorithm. Okay, plus even the space complexity also might get affected. So the algorithm needs to be smarter. So that's when it will happen when we don't like entertain the floating point values, or we don't use the rounding functions. Okay, and that's how we can proceed. So you can see the betterments of DDA algorithm, how it has been taken care of in the next lecture, that is Bresson line drawing algorithm. Thank you. I hope you have enjoyed this lecture. Happy learning. Enjoy computer graphics. Thank you.